All right, welcome back. We're going to take a look at exponent properties again. You probably got a basic idea of how to do a lot of the problems that deal with exponents. So today we're going to look at problems that require or have a division sign in them, so quotient properties. And so at the most basic level, we talk about questions like x to the fifth divided by x to the third. And we talked about how we can simplify x to the fifth divided by x to the third by subtracting the exponents. 5 minus 3 is 2, so this would simplify to x squared. What I want to give you a better idea of is where that comes from, and then how we can apply it to more and more difficult problems. If we look at x to the fifth is just the same as x multiplied by itself 5 times. X times x times x times x times x divided by x to the third, which is x times x times x. Now there's something that's real interesting that happens when we divide things that are alike. If we think about, I don't know, back to probably 4th grade, we start learning things like, well, 4 divided by 4 is 1. Or 7 divided by 7 is 1. That something divided by itself is 1. Now remember, these x's are just numbers. So if this x here is 7, this one down here is 7 as well. And so what I have is 7 divided by 7, or in this case, x divided by x. So this, x divided by x here, cancels out or turns into a 1. So this is just 1 multiplied by another 1 multiplied by another 1. And after we cancel those out, because they divided each other out, we're left with x times x, which is just x squared. So we kind of play this game of, well, who's stronger, the numerator or the denominator? Well, there's 5 x's here, there's 3 on the bottom, so the numerator is stronger. There's 2 more on the numerator, so in the end it simplifies to x squared over 1. So there's 2 x's in the numerator, there's no x's in the denominator, so we can put 1, but we don't need the 1, so a lot of times they write it as x squared. So that's called the quotient of powers property, and we can use it to do, lots of different problems. We can use it to do problems like x to the 7th over x to the 3rd, x to the 7th, y to the 3rd, all divided by x to the 5th, y. So they can make them longer, but we're still going to apply the same property. We're going to take a look at our x's, so I can draw a box around the x's. If this is all I was looking at, let's even do this. If this is all I was looking at, the answer to this problem would be x squared. There'd be 2 more x's on the top than there are the bottom. So part of my answer is going to have an x squared in it. Well, if I look at just this part here, y to the 3rd divided by y, there's the whole problem. Y to the 3rd divided by y, there's 2 more y's in the numerator than the denominator. So we could say y squared. Now sometimes it's the denominator that's stronger or has more multiplications in it. And so sometimes you'll see stuff like x to the 5th, y to the 3rd, all divided by x to the 8th, y to the 7th. In this case, the denominators have more of the variables in them. So when I go to look at the parts, the x to the 5th divided by x to the 8th, the x to the 8th is stronger. It has more x's here. And so when I start canceling out, 5 of these x's will cancel out 5 of here. But there's a total of 8, so there's still 3 more in the denominator. So when you go to write your answer is going to have 3 x's still in the denominator. These 5 are gone. These 5 canceled out with 5 of these, leaving only 3. And then we can look at the y's and do the same thing. Y to the 3rd divided by y to the 7th. Well, who's stronger, the numerator or the denominator? Well, there's 7 y's being multiplied together in the denominator, so there's more there. And so when I go to write my answer, there's 4 more y's on the bottom, and then everything's gone on the top. So what is left on the top? Well, if we think about it, all these x's that canceled out turn into 1s. These y's that cancel out are 1s. 1 times 1 is 1. So if there's nothing left in the numerator, we always put a 1 in there. So it's 1 over x to the 3rd, y to the 4th. And so that's kind of like the most basic idea. And then we looked at doing more and more complex problems as we went on. So we talked about level 2 problems. Well, yeah, that's great, well, Joe, I get that, but then you give me these hard ones and I don't know what to do. So one of the problems we gave on our practice problems was this problem here. 2a to the 3rd 2a to the third squared, all divided by a to the fourth, b to the fourth, that entire quantity squared. Now I agree, this doesn't look like the ones we just did, because this one uses properties we did last time and the new properties now. And so this is going to be just a longer problem, but we got to take it step by step. And one of the first steps I want to do is I want to get rid of the parentheses. And if you look at this, it's 2a to the third squared. So this squared here goes to everything in the parentheses. So if I wanted to think about it, I could take this squared and I could kind of think to myself mentally, well, that squared goes here, so 2 squared. And I also could think that squared goes to a to the third. So I could also think a to the third squared. Now we don't usually write it this way, number one, because it's messy, and number two, we can probably do that mentally. 2 to the second power is 4. And then we learned a to the third to the second power on our last video was a to the sixth, that we can multiply those. So 3 times 2 is 6. So we get 4a to the sixth in the numerator. And then in the denominator, we're going to do the same thing. This squared right here belongs to the b to the fourth and the a to the fourth. So when you see a to the fourth squared, because there's a parentheses, we use the power of the power rule. We're going to multiply the exponents. So 4 times 2 is 8. So on the bottom I have a to the eighth. And then we're going to do the same thing with the b's. We have b to the fourth squared, so that's b to the eighth. So a to the eighth, b to the eighth. And then we're going to look at seeing if we can simplify that any further. So now we took what we had here and turned it into a problem that we had earlier, so a problem that we just did. And so we're just looking to see if there's anything else I can do to simplify. Is there anything else I can do to cancel stuff out? If you have a coefficient, the numbers out front here are called coefficients. Coefficients. If you have numbers and there's nothing to reduce it with, that coefficient's just going to stay. So that 4 is going to come over to the other side, or past the equal sign, really. Nothing can happen there. But then I can look at my a's. I have a to the sixth here, but I also have a to the eighth here. They're being divided, so now this is one of those rules where we can say, all right, well, who's stronger? Where is there more a's? Well, there's more on the bottom. There's 2 more on the bottom, or the denominator, so it would be a squared. These 6's go away, so we don't have to write them up here because they cancel out 6 here and just leave me a squared. And then the b to the eighth is being left alone in the denominator, so we would just write it down here. So we can apply all the properties that we're learning to do even more and more difficult problems. And that's what I want you guys to try when you're looking at your quotient property practice problems, is just trying to figure out, all right, how do I apply the properties I already know, and then come in with questions that you still might have.